My name is Nikunj. I work at OpenAI. I'm a product manager on our API team. The team I work with is responsible for getting all of our models out in the API, which means we own like the core API primitives for OpenAI. So that is chat completions, the completions API, assistance API, and now the responses API. So wanted to over this talk tell you all about why we built the responses API, sorry, and why we think it's the right API primitive for the future of models and model capabilities that are about to come out of OpenAI. And yeah, with that being said, let's just dive right in. I'll probably stand here. Um, all right. So before we just a second. Okay. So before we understand why we're building the responses API, let's start at the very top. The first API that OpenAI released back in 2020, alongside GPT-3 at the time, was the completions API. And it was called the completions API because the models at the time were just things that completed text. So you would put your first few words right at the top. You would then ask the model to complete it. It's going to create like a new line token, introduction. It'll keep sort of typing and releasing more tokens until it released the special token that told it to stop, and then it would stop. So the completions API alongside GPT-3 was the first version of it. The types of applications that were built on top of the completions API were very text heavy. I think the biggest applications at the time were AI Dungeon and Copy AI. Copy AI was this role-playing game where you sort of explored this world and it sort of like turn by turn told you what's going to happen. And Copy AI helped people generate marketing copy for products and features that they were trying to get out there. And both of these applications were sort of using our models in a turn-based manner. The completions API was not meant to be used in like this user assistant manner, but they were already trying to like prompt the model, give some few shot user assistant examples, and then like do a user message and an assistant message and try to get it to complete it. That, coupled with the release of this amazing product in late 2022 called ChatGPT, really like solidified our models in this like user and assistant type of paradigm. And so what our research team did was they took the base GPT-3 model and they post-trained it or fine-tuned it to be really good at having user messages, assistant messages, user messages, and then replying to the assistant messages. So it was post-trained in this format. And so in early 2023, with the launch of GPT 3.5 Turbo, we released the Chat Completions API. So this is the second core API primitive that was launched. And by the way, this photo is of the team that's launching the Chat Completions API. I wasn't around at the time, but I was told that it was designed on a Friday and launched on a Monday. So it's like basically built over the weekend. And this is when the team was launching it. Chat Completions API is the de facto API for LLMs. I believe pretty much every AI provider out there supports some version of this API. But internally, we've been feeling like we're starting to like hit the limits of what the Chat Completions API can do, and that's what's motivated our next steps. I'm jumping ahead a little bit, but this I'm sure you're all familiar. This is what the Chat Completions API looks like: role system, role user, assistant user, and so on and so forth. And most importantly, this is a text in and text out API primitive, and it's a single turn API primitive, which means each time you call the Chat Completions API, we only talk to the model once, and we give you exactly what the model gives back in the form of an assistant message. So the types of applications that in 2023 and 2024 that got built on top of the Chat Completions API were Cursor, Duolingo, Klarna. Cursor, I'm pretty sure everyone here knows what Cursor does in terms of its coding agent capabilities. You had Duolingo, which was helping people learn languages. And Klarna was like really pushing the boundaries on automating their internal operations. So customer support, dispute handling, all the things that you expect a payments provider's internal operations to do. And all of them were prompting the models to connect them to their internal APIs. So the models themselves did not support tools at the time, but these models were being prompted to either like call the web, call internal databases, use calculators and stuff like that. And so based on that feedback, the team released something called function calling. So this was roughly in June 2023, that tools were introduced to the API. And so we went from user assistant to user tool assistant. And around that time, a lot of the code that was being written on top of the LLMs started to look like this, with while true being the agentic loop. And you would just sort of like go over and over with the LLM, call all the tools that it needs to call, and finally stop when it put out an assistant message. And so this became known as agents or the agentic loop. And this was the chat completions, how I think a lot of people use the chat completions API today. So keep this in mind. This is something new. This is not what the chat completions API was built for or really designed for, but it's like being used in this multi-turn manner to sort of give models access to tools and the decision or the autonomy to call different tools. At the same time, we saw models go from just text in and text out to support multiple modalities. So as you can see on the top over there, we had to sort of like make audio fit into the chat completions API in this like really weird manner where all the other fields are null, but like you now have this audio object. We sort of like started releasing these built-in tools like web search, and we had to like tack on this another object over here. And overall, we just felt like we were just putting way too much into the chat completions API, and we were like really sort of like, pushing the boundaries of what was possible in it. And it really like felt to us that we need to take a step back and build a new API primitive that would focus on the needs of the AI applications that are being built today. So what are the AI applications that are being built today? I think there are a couple of things that are very obvious. So first, AI applications today use multiple tools. We're no longer going text in, text out, and just conversing with the model. We're using the LLMs and connecting them to the outside world to take actions, to read data, and so on and so forth. The second thing is that things are inherently multi-turn. You talk to the model, you talk to the tool, you go back to the model, you go back to the tool. Maybe you get some input from a user or a human in the middle, and you go back to the model. And so things are inherently multi-turn. And so the API primitive needs to support multi-turn behavior a lot better. The third thing is multiple modalities. We just launched ImageGen in the API today, finally. That's a reality now. But outside of that, you have image in, you've got audio in, you've got audio out. Most models are becoming omnimodal today. And so multiple modalities are becoming more and more important. And the last thing I want to say is that things are moving on to long horizon tasks. So a lot of AI application building traditionally has been, how can I get the lowest latency? And how can I get this thing to like give me the fastest answer possible? I think there's a lot of appetite for having the LLM spend 5, 10, 20 minutes, do something very robustly, and give you this like really, really high quality answer. And we've seen this proven out with products like Deep Research in ChatGPT or Operator. And I think we're going to see a lot more of those kind of things going forward. So this is the problem statement. Like, how do you build an API primitive, a core API primitive for OpenAI that's able to handle these things a lot better? And our answer to that was, or is, the Responses API. So let's see what the Responses API looks like. At its very simple, in its very simplest form, Responses API is just 4 lines of code. So specify the model, specify the input, and you can talk to it. But you can tack on much more functionality on top of this to make it much more powerful. When we were designing the Responses API, our main design philosophy that we had in mind was called APIs as ladders. There's a really, really good article by Sebastian Bensusan, and I have the link over here to read the whole article. It's really an excellent article, and it talks about how you need to make things incremental. You need to make the easiest things super simple, and then gradually introduce more functionality as the developer sort of wants to do more and more advanced things. So developer needs to sort of climb the ladder to do more and more complex things via the API. So if you start off as a developer who's never heard of OpenAI or any LLMs or how these things work, you start off with the simplest example right there on the right, where you just have 4 lines of code. You're calling a model, you're putting in a prompt. And then maybe you choose to like expand your learning and learn about, okay, there are multiple roles. You can go user assistant, and you can do more advanced things. You can like fake conversations between the user and assistant to steer the model in a particular direction and do few shot prompting that way. Or you could use these built-in tools like the web search tool to allow the LLM to search the web. And so we wanted to make sure that our design is sort of very incremental, and this new primitive doesn't sort of like feel like much more complicated than what chat completions was. So this is the core part of our design. The second thing that we did was that we made sure that we are trying to address the while loop problem or the while loop design that we see a lot of people building on top of the chat completions API. So we can't do this in every single scenario, but when you're using built-in tools, so when you're using OpenAI's hosted file search tool or OpenAI's hosted web search tool, the responses API comes with a while loop built in or with an agentic loop built in, which means we'll keep looping the model and calling these tools, and we'll only stop when there's either a function call or when we think that we have the final answer, or when we need like more input from a human in the middle, or from the user of the model. And so what does that look like? So let's say that you've designed a responses API call. You're creating a personal book recommendation assistant. You use the file search tool to create some user memories. So say every user of yours has like a small notepad file with like their preferences on the types of books that they like to read. You have enabled the web search tool, and you have a function that sort of like displays the recommended books. In a single API call, well, this is starting in the middle, but let's just wait for it to loop. But in a single API call, you have your system instructions. Someone says that they're going on a long flight and they want some book recommendations. In the same API call, the responses API can call the file search tool to get user memories. It can then use those user memories to search the web for relevant information, and can then call the function to display the books. And so for someone that's like new to LLMs, they've just given this thing 3 tools. It's called all of them, and it's sort of solved like this pretty complicated task that required a lot of code writing, stitching together multiple third parties and stuff like that to begin with. Yeah, the thing I'd say about this is that this is only as powerful as the number of tools that our APIs can call. And so today we have basically 3 tools. We've got web search, we've got file search, which is like our RAG tool, and we have function calling. We also have computer use, which is under a separate model. But we're really excited about adopting like a broad ecosystem of tools that is being built on top of MCP. And so we'll be sort of making the responses API work really well with remote MCP servers as those things take off in the near future. And so then you could imagine like just, Slack tool, Stripe tool, SendGrid tool. You just like enable these things. You have a system prompt. You just in natural language tell the AI application what you want it to do, and then just like calls a bunch of those tools and solve those problems for you. So pretty excited about like how easy this thing is going to get once an ecosystem of tools is hosted and exists. The third thing I want to talk about with the responses API is we made a decision to make it stateful by default. The chat completions API is stateless by default. You have to pass the store equals true parameter to be able to see those things in your dashboard. Responses API is the opposite. It's stateful by default. And there are a couple of reasons for this. The first is that when I was first integrating with the OpenAI API before I even joined the company, I found it incredibly hard to like debug my responses. I think I was using LangChain at the time. It was like my first AI application that I was building. And I just like could not understand what is being sent to OpenAI and how this thing is working. Everything worked, but I like just could not make sense out of it. And I just like was, I was like, why can't we just see what was sent to the OpenAI API on the OpenAI dashboard. And it took me like a while, but like we finally have this view now with the responses API if you use our agents SDK, where you can see the exact set of steps your agent is taking, how it's handing off between multiple agents. And each time it creates a responses API call, you can see the tools that were enabled, the system instructions, the response. And I think this is like a much better developer experience when you're trying to build your applications and debug them. So that was one reason to make it stateful. The second reason to make it stateful was to reduce latency on really large workloads. So if you look at an application like Operator or a computer use model, what you're doing is you're sending it screenshots. You're like, here's a screenshot, tell me what to do. And then the model's going to be like, click on this particular thing. And then you send it another screenshot after you click on it and tells you, all right, scroll down a little bit. And really quickly, you have like 30, 40, 50 screenshots, which are these like high-res images that are in the context of the model. With chat completions or other stateless APIs, each of those images are just like making round trips back and forth, and that's needlessly like slow. And you have the same problem with long context on text and audio and stuff like that. So we've enabled this thing in the responses API called the previous response ID. So you can still do that whole like take all of my outputs, pass it into a new response, and like the chat completion style cycle of outputs to inputs, outputs to inputs. But if you don't want to do that, if you want to sort of if your payloads are getting really large, you can just reference an old response ID as the previous response ID, and the conversation just continues from there. And I think this is going to be like more and more a thing as agentic applications take off with really large context. All right, so just to recap, these were the motivations, and this is when we built the responses API based on it. But this is also something that our research team has been thinking a lot about. And so on the applied side, we built the responses API. But on the research side, we recently released our two new frontier models, which were O3 and O4 Mini. And a lot of the motivations behind the way O3 and O4 Mini call tools are the same as what we have for the responses API. So O3 and O4 Mini are marking the first time that we are moving all tool use from the end of the conversation to the reasoning step. So if you look at the reasoning models, they have this sort of like reasoning stage where they have chain of thought. They then end their reasoning stage, and then they give you a final answer. That's how they've been trained. And with all the models that we have so far, so the whole GPT series plus O1, O3 Mini, etc., all the tool calling happened in the final answer, where the model would think about something, and then it would like be like, and then it would say, call this tool to search the web, or call this function. O3 and O4 Mini mark a change where all of the tool use is moving up into the reasoning stage. So the model can think about things, call a bunch of tools, and then decide that it's done and give you a final answer. So what does that look like in practice? Some of you may have already tried O3 and O4 Mini in ChatGPT, but over here, someone has taken a photo, and they're saying, what's that ship? What's the largest ship over there? Tell me where it's from. And what the model is doing is that it's starting its reasoning process. It has a bunch of text snippets over there when it thinks. It then searches the web like 1, 2, 3, I believe like 3 times on top, and then 4 and 5 times. So it's like search the web 5 times in the middle. It has also used what we call internally the Python tool and externally the code interpreter tool to take the image, write some Python code, zoom in on that image, crop it, potentially rotate it, and do all sorts of things that you can do with images in Python. And then it is using all of those steps to come to a final answer that tells you what ship is in that photo. And that is like the future of agentic tool use. I think this is what our investment is going to be in, is that in the reasoning stage of the model is able to call multiple tools, make some mistakes, take a few steps back, take a few steps forward, and when it's done, give you that final answer. And The responses API version of what you saw in ChatGPT, and by the way, this is not live in the API yet. We're sprinting to make it live. So you can't access these tools. You can access O3, but you can't access the tools just yet. But this is what it's going to look like. You're going to create a responses object with your prompt like you typically do. You're going to enable a bunch of tools. And then the model is going to think. It's going to call a web search tool, it's going to think again, it's going to call the code interpreter tool to write some code to manipulate your image, it's going to reason a little bit more. It might call a function where it gives back control to the developer. The developer runs that function on their systems, hands back control to the model, and then it continues its reasoning process until it's sort of done and gives you the final answer, which is like a message object at the very end. And so, yeah, this is what the responses API is going to enable, and super excited about it. Quick peek into the roadmap over here. We're going to add many more tools. Like I said earlier, like this whole thing is only as powerful as the number of tools we support. We're really excited about MCP and remote MCP servers potentially taking off. And the vision over here is like you should be able to just specify a remote MCP server, and in the reasoning process of O3 or O4 Mini, is just going to call the MCP server, get the information, and then continue thinking about things. We're also going to look at enabling open API specs directly for services that don't have an MCP server. Code interpreter tool, data connectors to things like that you've already seen in ChatGPT, like Google Drive, et cetera, to get information. And the second thing we're really excited to do is enable long horizon tasks. So this is, exactly async mode. So have a response sort of think. We actually released O1 Pro in the API, which by the way is like absurdly expensive, but if you feel like trying it, you should. But that thing can think for like a good 20, 30 minutes on the hardest problems. And we really want to like have async mode and webhooks, deep research, O1 Pro, all of these things that are going to take really, really long times of inference compute and long times to think. And so we want to enable those in the API. And then the last slide I want to leave you with is where all of this is going. So today I just talked about the responses API, which is our synchronous and soon asynchronous, like turn-by-turn API primitive. We also have the real-time API. The real-time API is all about ultra-low latency, WebRTC, WebSocket-based connections, which is, and the focus for that is more on the audio-to-audio side. And on top of that, we have our suite of sort of higher level primitives. So we talked about tools, which are like web search, file search, et cetera. You want to build more things in the OpenAI dashboard to allow you to manage your prompts, conversations. You saw a little bit of our logs and tracing API. We now have an evals API, so you can start running some of your evals on the OpenAI platform. And then we have our model customization and distillation stack. And so things are coming together. There's a lot of work to be done, but I'm really excited that this like whole new stack of API primitives is coming together in the OpenAI API, and I'm hoping you all will be able to get a lot more value out of that platform outside of just accessing the models. And that's it for me. Thank you.